In the last tutorial, I outlined the different Lumetri video scopes found in Adobe Premiere. In this tutorial, we'll explore the waveform scope even further and use it to evaluate the exposure of some example images. The waveform scope is read from left to right, corresponding with the image, and the trace information is read from top to bottom, with the shadows at the bottom and the highlights at the top. You'll also notice these numbers here on the left ranging from 0 to 100 IRE, where 0 is absolute black and 100 is absolute white. On the right side of the waveform, there is another set of numbers ranging from 0 to 255 when the scopes are displayed as 8-bit, where 0 is absolute black and 255 is absolute white. To change the waveform to display scopes for images over 8-bit, such as 10, 12, or 16-bit, just select the drop-down menu and choose the float option. The values on the right of the waveform change to represent a range from 0 to 1.0, where 0.0 is absolute black and 1.0 is absolute white. A project with HDR images requires the scopes to display extended ranges. To change the scopes to display HDR, just select the drop-down menu and choose HDR. The numbers on the left display exposure levels in nits ranging from 0 all the way to 10K. On the right, HDR levels are displayed in floating point values ranging from 0 to 100. For the purposes of this tutorial, we'll display the scopes in 8-bit because we are using 8-bit images and use the IRE numbers on the left of the waveform ranging from 0 to 100. Using IRE values to measure video signals is easy to understand and is the most commonly used standard between software and hardware providers. Let's explore some important features of the waveform, starting with the different types of waveforms that can be viewed. Select the wrench icon, then waveform type, and you'll see 4 waveform options. RGB mode displays the luminance levels of the red, green, and blue channels. Luma mode displays luma or brightness values. YC mode displays the luma levels in green and chroma levels in blue. And finally, YC, no chroma mode, is similar to the luma mode and displays only the luminance levels but with a green trace. Let's change the waveform scopes back to luma mode. In a previous tutorial, I shared with you how the numbers on the left of the waveform range from 0 IRE to 100 IRE. I want to point out that when you are viewing the waveform using the luma mode, the numbers range from -20 IRE to 120 IRE. You will still use the same range of 0 to 100 IRE, where 0 is absolute black and 100 is absolute white. It is important to stay between this range because going below 0 will crush your shadows, and going above 100 will blow out your highlights, otherwise known as clipping. We'll address clipping in a later tutorial. Alright, let's evaluate some images. In this first example, we have an underexposed image. As you can see in the waveform here, most of the trace is collected near the bottom of the scope, indicating that we have an underexposed image. In the next example, we have an overexposed image where the trace is collected towards the top. The hard horizontal line across the top of the scope means that the image is overexposed and the highlights are clipped. And in this last image, we have a nicely exposed image where the trace is evenly distributed across the waveform scope. The waveform will take some time getting used to. What I suggest doing is that you practice by identifying the corresponding image elements in the trace of the scope. Playing back this clip here, you can see the relationship between the waveform trace on the left and the program monitor on the right. The lower levels in the waveform scope is our talent, who is darker than the landscape, buildings, or sky in the background. In later tutorials, I'll demonstrate how we can use the waveform to assist us in our color grading.